Okay, this time we're going to look at horizontal shifts in functions. So let c be a constant with c greater than 0. And the graph of f of x equals x plus c is the graph of y equals f of x shifted to the left by c units. And the graph of y equals f of x minus c is the graph of y equals f of x shifted to the right by c units. Sometimes this is a little hard for people to understand. You can understand it algebraically. Suppose you have a point on the graph y equals f of x. That means y1 equals f of x1. And then you take the point x1 minus c, y1. Then if you put x1 minus c into the equation y equals f of x plus c, you get y equals f of x1, and that must be y1. So this point is on the graph of y equals f of x plus c. And similarly, you can see that the point x1 plus c, y1 must be on the graph of y equals f of x minus c. Now see this point, x1 minus c, y1, has exactly the same y value as the point x1, y1. So it's actually c units to the left of this particular point. And that means that the graph of y equals f of x plus c is c units to the left of the graph of y equals f of x. That might be a little too abstract. Let's look at the function y equals x squared. And let's add a 3 to the x and subtract a 3 to the x and see what happens. So here we have y equals x squared, so we have 25, 16, 9, 4, 1, 0, 1, 4, 9, 16, and 25 here. And so the corresponding points in the graph are minus 5, 25, minus 4, 16, minus 3, 9, minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. Now let's look at some points on the graph of y equals x plus 3 squared. Well, if we take minus 6 plus 3 squared, we get minus 3 squared, which is 9. We get the point minus 6, 9 is on the graph. Also, minus 5 plus 3 squared, pardon me, there should be a square there, is minus 2 squared, which is 4. Minus 5, 4 is on the graph. Minus 4 plus 3 squared is just 1. Minus 3 plus 3 squared is 0. And so we have the point minus 3 zeros on the graph. Minus 2 plus 3 squared is 1. Minus 1 plus 3 squared is 4. And 1 plus 3 squared is 16. And we have lastly 2 plus 3 squared is 25. Point 225 is on the graph. Now, according to what I described above, this graph, the graph y equals x plus 3 squared, should be the same as this graph, except it's shifted to the left by 3 units. And check what happens here for these 2 points, minus 6, 9, and minus 3, 9. We have that they have the same y value, so they're directly across from each other. And this one, minus 6, 9, is exactly 3 units to the left of this one. And likewise, minus 5, 4, its y value is the same as that of minus 2, 4, except minus 5, 4 is exactly 3 units to the left of this one. And you'll see that all of these points that you get from each of these x values are exactly 3 units to the left of the ones I'm joining to them by these lines. This point 225 is exactly 3 units to the left of the point 525 on the graph of y equals x squared. And obviously there are points corresponding to these two on the graph as well. How about y equals x minus 3 squared? Well, we have minus 2 minus 3 squared here. It's 25. Minus 225 is on the graph. Minus 116 is on the graph. 0, 9. One, 4. Sorry, that should have been a square there. Didn't really matter. 3, 0. 4, 1. 5, 4. And 6, 9. And again, we see here that this point minus 225 has the same y value as the point minus 525 on the graph y equals x squared, except minus 2 is 3 points to the right of minus 5. So this point shifted 3 units to the right. Likewise, minus 116 is the point minus 416 shifted 3 units to the right. We shift this one 3 units to the right and we get 0, 9. Shift this one 3 units to the right and we get 1, 4, etc., etc. We'll see that all of these points here are the corresponding point shifted 3 units to the right. Let's draw some of these graphs. This one I'll draw in green. Y equals x minus 3 squared. And it should be the graph of y equals x squared shifted 3 units to the right. And the graph of y equals x plus 3 squared should be the graph of y equals x squared shifted 3 units to the left. Okay, let's have a look here. Our highest point on the graph is 25, so we're going to let this run from 25 to minus 25. We'll mark the y-axis off in steps of 5. And we'll just mark single units on the x-axis. I can see I've already gone off scale a little bit on the left, but I hope you'll forgive me. That's x and that's y. And now, of course, y equals x squared should be very similar to before. We have 0, 0, minus 1, 1, 1, 1, minus 2, 4, and 2, 4, 3, 9, minus 3, 9, 4, 16, minus 416, and 525, and minus 525. And we got our bowl-shaped parabola as we did before. Might go through there more smoothly. And it should all run very smoothly like a bowl around there. Okay, let's sketch what we've got for y equals x minus 3 squared. We have the point minus 225. This is way up here. And that's exactly 3 units to the right of this point minus 525 on the graph. Minus 116 is going to be exactly 3 units to the right of this point. 0, 9 is going to be 3 units to the right of this one. 1, 4 should be 3 units to the right of this one. 2, 1 should be 3 units to the right. Sorry, that one was 3 units to the right of that one. This one should be 3 units to the right of that one. And 3, 0 should be 3 units to the right of 0, 0. 4, 1 is here. 5, 4 is here. And that's going to be 3 units to the right of this one. And then we should have 6, 9 here. And so we see everything gets shifted to the right by 3 units here. So again, we have exactly the same bowl-shaped, except every point on the graph of y equals x squared gets shifted to the right by 3 units. And you have a similar thing with y equals x plus 3 squared. Let's just distinguish what's going on here. Y equals x plus 3 squared should be this blue graph shifted to the left by 3 units. So let's see how that works. We have minus 6, 9 on the graph. And that's that point shifted to the left by 3 units. And we have minus 5, 4, minus 4, 1, minus 3, 0. You see that's the point at the origin shifted to the left by 3 units. And then it should start climbing again. Minus 2, 1 is this point here shifted to the left by 3 units. Minus 1, 4, 0, 9 is this point shifted to the left by 3 units. 1, 16 and 225 is the last one we have recorded, and that's that point shifted to the left by 3 units. So we have the entire blue graph gets shifted to the left by 3 units, and the trend continues, and that gives us the graph of y equals x plus 3 squared. Okay, so the point of that is just to show you how it works with a particular example. People usually have a little trouble believing this. They usually expect that the x plus c shifts everything to the right by 3 units, whereas it's exactly the opposite. However, once you realize what's happening, you can sketch graphs without all of this detail. Once you know the basic graph of y equals x squared and which way it shifts, then you can just sketch the graph of, say, y equals x minus 3 squared pretty simply. It would be good if you tried to do that for these graphs, and then have a look at the next video to see the solution. In particular, this last one, h of x, is going to be, you're going to have to break it into steps, and it's going to be a combination of 2 shifts. So check it out, and then check out the next video to see if you have the answers correct.